Welcome to the video lecture for Chapter 1, Section 5. This is for College Algebra. My name is Jorge Gabriel. So the objectives for this particular lecture are going to be, we're going to use interval notation. We're going to use properties of inequalities. We're going to solve inequalities, and we're going to solve combined inequalities. So the first one is using interval notation. So an open interval is denoted by parentheses a and b, close parentheses, consists of all real numbers x, for which x is less than x and x is less than b. Now a closed interval denoted by a bracket a and b consists of all real numbers x, for which a is less than or equal to x, less than or equal to b. Now, half open or half closed intervals are the following: parentheses a, b, bracket, consisting of all numbers x, for which a is less than x and x is less than or equal to b, and bracket a, b, close parentheses, consisting of all real numbers x, for which a is less than or equal to x and x is less than b. So we have open interval, closed interval, half open or half closed intervals. And so here, open interval, there's the graph for the closed interval, the half open, also for the interval that a is from a to, including a to infinity. Also, x is greater than a. You see the graph and the interval notation for that. X is less than or equal to a, x is less than a, and then all real numbers. So writing inequalities using interval notations, we're going to write each inequality using interval notation. So for a, we have 1 is less than or equal to x less than or equal to 3. For b, we have negative 4 is less than x less than 0. And for c, we have x is greater than 5. And then for d, we have x is less than or equal to 1. So the first one describes all real numbers x between 1 and 3 inclusive. So in interval notation, we write it with brackets. Bracket 1, comma 3 bracket, close bracket. For b, negative 4 is less than x less than 0 is written with parentheses. And for c, x is greater than 5, again parentheses to positive infinity. And then for x is less than or equal to 1, we have half open, which parentheses negative infinity 1 bracket. Here, writing intervals using inequality notation. So we're going to do the opposite of what we did in the first example. We're going to write each interval as an inequality involving x. So for a, you can see that we have bracket 1, 4 parentheses, and b, and then c, and then d. So for a, that simply tells us that 1 is less than or equal to x, less than 4. So x lies between 1 and 4, with 1 being included in this interval or being inclusive. For b, we have x is greater than 2. For c, we have brackets on both ends. That means that we have x is between these two numbers, including the endpoint. So 2 is less than or equal to x, less than or equal to 3. And then for d, we have x is less than or equal to negative 3. So we're going to use properties of inequalities. Non-negative property for any real number a squared is greater than or equal to 0. And so if a is less than b, then a plus c is less than b plus c. If a is greater than b, then a plus c is greater than b plus c. So addition property of inequalities. So if a is less than b and c is greater than 0, if then a plus c is less than b plus c, and you can see it here in the number line. And then for b, if a is less than b and c is less than 0, then a plus c is less than b plus c. Multiplication property for inequalities. I'm not going to read them all, but you can see them listed there. So reciprocal property for inequalities. If a is greater than 0, then 1 over a is greater than 0. If a is less than 0, then 1 over a is less than 0. If 1 over a is greater than 0, then a is greater than 0. And if 1 over a is less than 0, then a is also less than 0. So we're going to go ahead and solve some inequalities. And so these are the procedures. I'm not going to read them all, but first we simplify as much as we can. We add or subtract, we multiply or divide, and so we're trying to do the same thing we do when we solve an equation. So just also remember that procedures that reverse the sense of direction or the sense of direction of the inequality symbol. If we multiply or divide by a negative, by the same negative value expression, we have to flip the direction of the inequality symbol, or we can simply just change the directions. And I spoke about this in class. When we solve it, we do want the variable on the left because it kind of helps us to determine which way our graph is going. So here we have the first inequality. We have 4x plus 7 is greater than or equal to 2x minus 3. We're going to solve it and then graph the solution set. So the first thing we do is subtract 7 from both sides. And then we're going to go ahead and combine like terms and then subtract 2x from both sides. And then so we end up with 2x is greater than or equal to negative 10. Divide both sides by 2. And we get that x is greater than or equal to negative 5. So the solution set is all values x such that x is greater than or equal to negative 5 using interval notation. You can see it there and in the graph. We're going to solve combined inequalities. So we're going to solve the inequality negative 5 less than 3x minus 2 less than 1. We're going to go ahead and graph the solution set. So remember that the inequality, that is also equivalent to two separate inequalities. So we can solve it with two separate inequalities, so we can solve it with one. I tend to just solve it with one as opposed to breaking it up. And so but when you do that, you end up with your two solutions. X is negative 1 is less than x, or x is less than 1. So the solution set of the original pair of inequalities consists of all x for which negative 1 is less than x and x is less than 1. So what I like to do is take the one where it says negative 1 is less than x and flip that one, so it would read x is greater than negative 1. And then if we do flip this, you can see that the arrow will be pointing to the right. This one's already set up the way that I like to set it up, which is pointing to the left. So it tells you that the solution set is between negative 1 and 1, not including negative 1 and 1. So we're going to use the reciprocal properties to solve inequality. So here we have 4x minus 1 raised to the negative first power is greater than 0. So then what we do is we rewrite it. So then we have 1 over 4 minus x is greater than 0. And then, of course, the reciprocal property tells us that we can just simply rewrite it not as a fraction. We can just go ahead and get to the denominator. So we have 4x minus 1 is greater than 0. And then we solve for x. We get x is greater than 1/4. And in solution set is all x such as x is greater than 1/4. That's the interval notation and the graph. So here's an example. Electricity Ohm's law states that E is equal to IR, where E is the voltage, I is the current, and R is the resistance. So an air conditioning unit is rated at a resistance of 10 ohms. If the voltage varies from 110 to 120 volts inclusive, what corresponding range of current will the air conditioner draw? So we go ahead and set up this inequality. So 110 is less than or equal to E less than or equal to 120. We know that E is equal to IR, so we can replace E with IR. And then we do have a value for R, which is 10. So that we end up with 110 less than or equal to I10 less than or equal to 120. Divide all three by 10. And this is what I was talking about before. I like to solve them. If I have a combined inequality, I just solve it this way rather than separating it. And then so we end up at that 11 is less than or equal to I less than or equal to 12. So the air conditioner will draw between 11 and 12 amps of current inclusive. And that's the end of 1.5. Thank you.